Okay, this is the second video for more notes in your notebook for section 5.2. If you have not watched the first video, please watch that first. This is a couple more ways to integrate based on, so we're going to be using LNs and using that process. So the last two, we looked at some dividing, so remembering our algebra skills. In this one, we're going to have a couple ways to use U substitution. In the first way, we have talked about this process before, but it's when we use U substitution and we have extra x's. We have x's that U substitution doesn't take care of. And then also we're going to get to a point where we have one term on the bottom. And we talked about that yesterday as well. So in U substitution, we are usually going to take what's on the bottom or whatever is going to make this less complicated. So in here, if I had U as x plus 1, that would make this less complicated, which would mean du is just equal to 1 dx, or you can just write dx. So if I rewrite this, I would have 2x doesn't get accounted for in our du. So it's still there. But on the bottom, I can rewrite that as u squared, and dx is du, so I can just change that to du. But now I have a problem in which I have mixed x's and u's, and remember that is not okay. All x's or all u's are your options. So we need to figure out a way to get rid of this x. Well, remember, extra x's means we use our u equals equation and solve for x instead of u. So that would give us x equals u minus 1. So this is going to be u minus 1. The 2 in the front, I'm going to move to the front. So it's just multiplying. I'll multiply my answer by it later. So x will be u minus 1 over u squared du. I have one term on the bottom. We've talked about this, how that means that it's going to be divided into each term on the top. So this integral is really 2 times the integral of u over u squared minus 1 over u squared u. And we can simplify this a little bit before we're ready to integrate. So this would be 2 times of u over u squared. When I simplify that, I get 1 over u. And I'm going to leave it as 1 over u because that is something that I can integrate. However, I am going to write 1 over u squared as u to the negative 2 du because I can't integrate other exponents than 1 on the bottom. So now I have 2, and it's all times the integral. 1 over u will become the ln of the absolute value of u. And I have minus, so this is u to the negative 1 divided by negative 1. And this is all plus c. There are a couple things we could do next. We could also distribute this 2 and put our x's back in. So u is x plus 1. So we have 2 times the ln of the absolute value of x plus 1. And then 2 negatives will make a positive. And we have x plus 1, the negative 1, and that's also multiplied by 2. So don't forget to distribute that 2 to both of them. And then I have plus c. So this is fine as an answer, or you could simplify this and the squared could move. So we could have the ln, squared is always positive, so we can drop our absolute values. And we can write this as plus 2 over, because this is a negative 1 exponent, x plus 1 can move to the bottom, plus c. Either one of these answers is acceptable as a final answer. One of them is just more simplified than the other. All right, let's look at another example. In this integral, we have 2 things. We have a product rule and a quotient rule, but we don't have either of those for integrating. So we are going to have u substitution. And in this u substitution, ln of x is more complicated, so that's what our u is going to be. So in this case, the first thing that I'm going to do is split these up, because I can split these up into factors of 1 over x times 1 over ln of x. Just like 6 can be 2 times 3. So splitting that up will help me see the pattern a little bit better, and then u can be the ln of x. which means du is 1 over x dx. So I need 1 over x and dx. Well, here's dx. Here's 1 over x. So both of those things make du. And ln of x is u. So all of this will turn into 1 over u du. And that is something I can integrate pretty straightforwardly. So I get the ln of the absolute value of u plus c. We are going to have to put our x's back in. I'm just going to go ahead and leave a space and then put my x back in, which is ln of x. So in this case, I do have the ln of an ln of x. I do have to leave the absolute values because while ln's can't take in a negative, they can put out a negative. So that would be my final answer, and there's nothing that I could simplify there. So let's look at another example. The reason why I can't just integrate this regularly is I have the square root of x plus 1. So this one, we are still going to use u substitution, but u is not going to be the entire denominator because I can't have u be too big. So u is actually just going to be the square root of x. And if we found, so we can also write that as u to the x to the 1/2. If we find du, that would give us 1/2 x to the negative 1/2 dx, which is 1 over, this is a negative, so it would be 2 square root of x dx. Well, I don't have 2 square root of x on the bottom. And this is about to become u, so I'm not going to have any x's. So I'm going to have too many x's. So one thing, if this is really complicated and it's not something that we can put in, what we want to go back to is our u equation. And we want to solve for x. So to do that, we can square both sides. We have u squared equals x. Now we might use this, but we might also want to get dx in this way. There's another way to go about this. So if the derivative of u squared is 2u du, then the derivative of x is just 1 dx, or I can just write dx. Well, this is helpful because now I can just take dx and write these two things to make up for it because those are equal. I can write this side or this side. Well, I already have dx, so that can turn into 2u du. And this is going to be 1 over square root of x is u plus 1. And that's what I'm going to integrate. So let's switch this around a little bit. We have 2u can be multiplied to the top. The 2 is a whole number, so I'm going to move it out front again. Don't worry about it for now. Move that u to the top, u plus 1. Now this is in the first video when we have the same exponents or same degrees on the top and bottom. It's a fraction that we can't split up in any other way. Then we have to use division. So we are going to divide this as u divided by u plus 1. So when we divide this, u, to get u, we just multiply by 1. And then distribute this out to both. So we have u plus 1. And our process says to subtract these two things. So we have u minus u is 1, 0, and negative 1 makes negative 1. So this is my remainder. So I have minus 1 over u plus 1. So this is what I'm going to integrate. So I'm going to write this in the integral. 2 times the integral of 1 minus 1 over u plus 1 d. Well, here, so 2 times, when I integrate 1, is just 1x, or 1u. Careful here. Okay, so that's a good point to make. du, we're putting u's back in, so 1 is going to become u. So be careful because it tells you which variable you're putting in. And this is 1 over something, so our integral is going to be the ln of the absolute value of whatever that something is, because the derivative of 1 plus u is 1 on top. So it's going to be just u plus 1. Kind of skip the u substitution there. And then plus c. And then we can put our x's back in. So we'll distribute this 2 again and put our x's. So u is the square root of x. So that's what we're going to put. So we have 2u minus 2 ln of u plus 1 plus c. And then put our x's back in. We have 2 times the square root of x minus 2 ln the absolute value of square root of x plus 1 plus c, which is fine to stop here, but if you wanted to simplify this, 2 square root of x is just going to be 2 square root of x. But this squared can move up. Since it's an even number, we can get rid of these absolute values. So we can write this as ln of the square root of x plus 1 squared plus c. So that's another correct answer. Now, this last one is trig. And at first, it looks like we can just integrate it. But let's look at our integral list. If you go back in your notes, this is your integral list. We can only undo derivatives. So over here, we can integrate sine, cosine, secant squared, secant, tangent, not just tangent, secant squared, cosecant, cotangent. We have no integral rule for just tangent. So when we look at this problem, what we have to do is rewrite it. So when we use trig, sometimes we can rewrite using identities, which are things that you need to know. Some people are more familiar with them than others. Well, we have an identity that says tangent is the same thing as writing sine x over cosine x dx. Well, the reason why we want to use sine and cosine is because those are both things that we can integrate. They're also both things that we can take the derivative of. So once we do this, it's kind of like changing if we had 2 is the same thing as 2 over 1. So tangent is the same thing as sine over cosine. So we're going to use u substitution. We're pretty much always going to take what's on the bottom. So u is going to be cosine of x. So du, if we look back at our list, cosine, the derivative of cosine is negative sine. So negative sine x dx. Well, we have dx, we have sine, we just don't have a negative, so I need to put a negative in, take a negative out. So I have the negative integral, sine and dx, and negative make du. 1 over cosine of x is u. This, I can integrate. 1 over u is the ln of the absolute value of u. I have a negative out front, and I have plus c. The last thing to do is to put cosine back in. So this is the negative ln, the absolute value of cosine of x plus c. Cosine can give out negative answers, so you have to keep those absolute values. You could move the negative into the exponent, but we aren't going to really do that with the sign. So that's it for this one, and that's how it's going to be simplified. There's nothing else to do. So these are all of the different ways that we can integrate and all of the different processes that we need to be aware of.